Just want to advise everybody that the webinar is going to be recorded, so it's going to be available later if you want to review anything, or if you may have a colleague who may be interested as well. The webinar today is about the introduction of the SILStat field data collection program. SILStat is a live event recording and monitoring tool that we've developed here at exida and have been successfully using on a couple of pilot projects. Right now it's 10 a.m. on the East Coast in the United States, so I'm inclined to say good morning, but it may be good afternoon or good evening for you already. My name is Iwan van Beurden. I'm the Director of Product Development here at exida. I support end-user projects. I support manufacturer projects and the exida certification activities. I'm responsible for the exSILentia software and as well as the SILStat software, which is kind of falling under the exSILentia umbrella. I'm a member of the ISA 84 committee, and I perform a variety of functional safety tasks, from SIL selection to SIL verification, as well as on-site functional safety assessment and audits, 61511, 61508 assessments. I'm an instructor for exida as well as for ISA. exida was founded in 1999, and over the years we've grown quite a bit. We've got some main offices around the world, and we have some regional offices as well. I'm located in the Sellersville, Pennsylvania office, which is just north of Philadelphia in the United States. The exida products and services, we do consulting for process safety, IEC 61511, or the NC ISA 84.00.01 standard. We have control system security consulting for the ISA S99 standard, as well as alarm rationalization, alarm management services. We do product certifications, for certification for IEC 61508, the international standard for electrical, electronic, and programmable electronic safety-related systems. We do functional security and the security lifecycle assessments, and then overall cyber security assessments. Training classes for process safety, control system security, alarm rationalization, either on-site, off-site, through the web, whatever works best for you. There's a variety of engineering tools. So we have the exSILentia suite with tools like FACS, and SILalarm, SILect, Silver, about to be released layer protection analysis tool, LOPAX, proof test generator. We have the SILStat software, which we're going to be talking about today, and there's some manufacturer-oriented tools like a safety case database and a SILcal tool that we use to support our certification work in functional safety. We have several references, databases. Most of you may be familiar with the Safety Equipment Reliability Handbook database with failure rates and failure modes of equipment used in safety instrumented functions. We've published several textbooks. We have a textbook that addresses the IEC 61508 safety life cycle, the development process, a practical SIL target selection book, and so on. Market studies are available. And then finally, that's kind of lined up with the product certification. We do the professional certification. We're supporting the Certified Functional Safety Expert program, Certified Functional Safety Professional program that are run by the CVSE Governance Board, but that are certified by exida certification. So today we're going to talk about the SILStat software and what it can do. And in order to get that started, I think it's good to look at the overall exida end-user software and see where that software fits into the safety lifecycle. So that's what I wanted to start with. So we're going to look at the IEC 61511 safety lifecycle, and most of you are familiar with this. We have At the top of the slide, let me get my pointer ready. We have our risk analysis and protection layer design. We allocate safety functions to safety instrumented systems and other means of risk reduction. There where we have a safety instrumented function, we'll write a safety requirement specification. If it's another means of risk reduction, which could be, for example, an alarm or a relief valve, the standard doesn't really address that in any detail. So we have a design and then other means of risk reduction that's addressed, but not really in any level of detail as we have for safety instrumented functions here. Installation, commissioning, and validation, operation, maintenance, and then eventually modification and decommissioning. Throughout the life cycle, we have verification activities. We have an overall life cycle structure and planning in place, as well as functional safety management to ensure that functional safety is maintained throughout the life of the system. So if we look at the exSILentia software, then we see various modules of the exSILentia software addressing the various phases of the life cycle. We have a FACS module, process hazard analysis tool. We have import capability that addresses the risk analysis and protection layer design. We have the SILselection tool, SILect, that addresses the allocation of safety functions. We have a safety requirement specification tool, and in our case, we split it up into two separate tools, in the process SRS and a design SRS tool. The process SRS documents all the requirements that come out of the process hazard analysis and SILselection, everything you need to know in order to come up with a conceptual design for your safety instrumented function. That conceptual design is evaluated through the SIL verification tool, the Silver tool. And out of the Silver tool, we will have a bunch of requirements with regard to the detailed design of the safety instrumented function. And those requirements we document in the design SRS. Now, IEC 61511 only talks about one SRS, where these requirements are combined, but that means that it's a document that is fluid. You'll have to update it once you've completed your conceptual design. And since in many cases the process hazard analysis and the conceptual design are done by different teams, sometimes it's a contractual document. Updating that contractual document is very painful. So we decided to split it up and focus on the process safety up front, and then the actual design requirements after the conceptual design is completed. I talked about other means of risk reduction. We have our SILalarm, our alarm rationalization software that you can use to help you prioritize the different alarms. There's a proof test generator that will help you to come up with proof tests for the safety instrumented function equipment items as they have been selected in the Silver tool. So based on the selections in the Silver tool, this proof test generator will come up with proof tests that you can implement to achieve certain level of proof test coverages for the equipment in your safety function. More as a management of functional safety, overall life cycle aspect, we have the life cycle cost. It doesn't really fit into the concept of functional safety. We don't really care about costs typically. Hopefully, most people do. But this allows you to compare different designs and see what the overall life cycle cost is of different designs. One out of one sensor may be less expensive than 2 out of 3 sensor voting, but over the life of the system, fewer proof tests. For example, this overall life cycle cost of that 2 out of 3 voting may be cheaper than the 1 out of 1. Of course, depends on your specific rates, etc., and procurement costs, which are all parameters that you can specify. So this is the suite of exSILentia software tools. So early on in the 2004, 5, 6 time frame when IEC 61511 was relatively new, that was adequate. People were focusing on the analysis and realization phases, and they weren't really looking at the operational phase. But you'll get to a point where analysis and realization work is done, so we're going to start operate. Well, what are we going to do now? Obviously, we need to do proof tests, but what else is required? And the picture I have here comes from 61508, and it's addressed in 61511, but unfortunately that picture is not in 61511. And I really like this picture because it shows us what we need to do during operation. Now, during operation, we'll have maintenance reports, we have operational reports that may document failures and demands on the safety and some function, or more general demands of the process. Which could mean an operator response, or a control function response, or the safety and some function response. But these reports indicate certain incidents, and we are required by the standard to document those failures and demands in a database so that we can review those at a later time. So that's one of the things that we need to do. We need to record our actual experience. We need to have proof of our actual experience and what we've done. We evaluate those failures and demands, and if we indicate, if there's an indication that there's a systematic failure in our design, that would lead immediately to a modification request. So an example, for whatever reason, the trip limit was set at, let's say, 90% of the scale, and it should have been 85% of the scale, and you run into an issue where the overfill protection was basically too slow. You may have a little spillage, and you want to adjust that. That would be a systematic issue. You're going to change the design of your safety instrument of function in this example by just changing one parameter. So that would lead immediately to a modification request. Now, during your analysis and realization phase, you've made certain assumptions. You've made assumptions with regard to how often you expect the process to be upset, how often you expect the process to present a dangerous situation that needs to be responded to. You've also assumed certain failure rates for the equipment that you're using to protect against the different hazards. We can talk about failure rates for safety and function equipment, but at the same time, you've assumed certain probabilities of failure for example, a relief valve. So what the standard requires is that periodically we compare the actual performance with the assumed performance. And if we conclude that our actual performance is better, failure rates are lower, demands happen not as frequent, then obviously our design is adequate. We're protecting or maybe providing even more safety than we really need. Now, if the numbers line up exactly, then you would be spot on. If you come to the conclusion that your demands occur, let's say, once every 5 years, and you assumed once every 50 years, then you're an order of magnitude off in the wrong direction. Your process is apparently more hazardous, higher risk than you originally expected. So we need to do this performance comparison. And if we conclude that the demand or failure rates are above predicted, we need to create a modification request. We need to update our risk analysis. Maybe we need to go back and update our layer of protection analysis. Maybe we need to go back and update our SIL selection. Maybe we need to go back and update our safety and semantic function. That 1/1 sensor voting, maybe we need to change it to a 1/2 sensor voting. Or maybe that one valve is not adequate. Maybe we need to do something different. So anyway, those could lead to modification requests. In order to do this comparison, we need to have data. And there may be some companies that are collecting data, and I've had the privilege to visit several end users, and they've shared what they did so far with me. I remember one refinery where they did a very detailed analysis on all the relief valves, and that was documented in a database, easily retrievable information. But at the same time, they didn't record a single thing for safety and semantic function equipment. So you could say, well, the relief valve data was adequate, but not necessarily for the safety and semantic function. They simply didn't have a means to record this information. Quite often, information doesn't get recorded unless there is a work order associated with it. So if you have a problem with a transmitter and you can solve it by simply rebooting the transmitter, that most of the time doesn't get recorded, and that could lead to very optimistic conclusions about the failure rates of your transmitter. There may be a serious systematic issue that you get rid of every, let's say, 3 months by rebooting that transmitter, but that may be an indication that the transmitter is not suitable for your application. All right, so we need to have data, and we need to be able to compare the data to our assumptions. And where do we get the data from? Well, we need to record that data through our normal life. So if we look back at our overall life cycle, where the different pieces of exSILentia are fitting in, you will see that the operation and maintenance, yeah, we talk about proof test generator, meaning we can help you set up proof test procedures, but the actual recording of proof tests and recording of failures, that's basically where there's a gap. And that's where our SILStat software comes in. SILStat solves that problem. It is the live event recorder of demands and failures, and will also help you in recording different maintenance activities that you do, the different proof tests that you do, and so on. So that's what we're going to look at in the remainder of this webinar. SILStat live event recording and monitoring. So very simple. What does it do? We record functional safety related statistics and performance metrics. All right, let's take that a little bit outside the box. Yes, the original scope of SILStat was to address that specific gap in the functional safety life cycle for the operational phase. But everything that you see here, everything that we apply here to safety instrument function equipment or equipment that is protecting against certain hazards, we can extend that to normal control equipment as well. But for the case of the webinar here, I'll focus on the functional safety aspects. So we can record live events, demands, the frequency at which a hazard occurs. And I will show you we can record what layer of protection is successful and what layer fails, if any fail. We record proof tests. Proof tests, obviously we do proof tests to determine if there are any failures that were unrevealed during normal operation. Can we detect any failures that were not detected by automatic diagnostics during normal operation? And we're looking at recording any failures, having that data. But at the same time, SILStat can be used to document that you have performed your proof test, and you can use it to show compliance to the requirements of IC 61511. Show that you're compliant to, I've done my proof test per the proof test schedule. You can use it as a scheduler tool. Maintenance activities. Some products require specific maintenance. Well, we could talk about gas sensors. Let's say an ammonia sensor. The actual sensor module will need to be replaced based on your specific conditions. If you're in a chicken farm, that may be needing to replace every 2 weeks. If you're outside in a normal plant, maybe 6 months. But there's a preventative maintenance that needs to be performed every so often. You can record it and you can document and show that yes, you have followed the manufacturer's safety manual and you have performed your maintenance activities per the requirement of the safety manual that is part of a product certification. And obviously we can record failures. We can record if products are failing and what type of failure it is and so on. There's a couple of different terms that we use in SILStat, and I just figured it's useful to express them here so that we're all on the same page in case I refer to one of them later. So we have a hazard scenario. A hazard scenario refers to a specific hazard with all applicable protection layers in sequence of operation. So a hazard scenario could be overpressure in a vessel, where a control function interlock is the first layer of protection, followed by an operator, followed by a safety instrument function, followed by a relief valve. In SILStat, you can manually define all this. However, if you've done your SIL selection in exSILentia SILect tool, and obviously done your SIL verification in the exSILentia SILect tool, all this can be automatically imported out of exSILentia. And basically, with a click of the button, you have your hazard scenario laid out in the SILStat tool. We talk about devices, which is a specific equipment item with a unique serial number. Again, we can import this stuff out of the SILect tool or the Silver tool. You can also manually define it, But again, if you use the exSILentia software, this setup is a breeze. And then we talk about addresses, which is the physical location of a device. And that could, for example, be the country, the site, the plant, and the specific tag of that device. So in the tool, we keep track of devices and we keep track of addresses. So a device may be installed in a certain tag. So we have a pressure transmitter that is installed on PT101. If that pressure transmitter, for whatever reason, fails, we remove that device from PT101, from the PT101 address, and we put a new device in, but we keep track of what's happening to that original transmitter. Now, is it discarded? Is it repaired? Does it go back into the shop? Does it go in the storeroom? And so on. So maybe that same device, maybe not as likely with a transmitter, but maybe that same device is eventually going to be installed somewhere else in the plant, maybe PT301. If it fails again, we have all this record associated with that particular unique item. At the same time, you may have issues with a specific address location. Maybe that location is so awkward that people are walking into the transmitter and thereby, maybe causing some extra vibration or some other problems. So we're also able to look at specific address locations and see if there's anything going on with those address locations. Okay, so how do you set up SILStat? It's not an empty database. Now, we have defined FAIR taxonomies. We have pre-configured proof test procedures that you can select from. If you use exSILentia, you can export a lot of this stuff directly out of exSILentia. SIF tags, IPL relationship, plant hierarchy, and I have a couple of screenshots that will show that. But the overall benefit is that there's a reduced initial expense. You don't need any, of course, we'll show up. We'll help you get things started, which is actually part of our standard offering. We're not charging you out of the wazoo to have people on site to get you up and going. But you buy the software, you import from exSILentia, and within a day you're probably going to be able to start recording information in the tool. So one of the things that we've implemented in SILStat is a pretty advanced proof test generator. And it will allow you to specify individual proof test steps with pass-fail criteria. Now, in some cases, this means that you will have to update your proof test steps to basically, instead of measure a certain value and ensure it's in a certain range, you'll have to say measure the value and record the value. So you have to, in some cases, modify the proof test steps a little bit so they can really be answered by a certain pass-fail criteria. When you perform the proof test, the user of the tool will record factual data. The user of the tool will record what he's actually measuring. He's not going to conclude if the proof test passed or failed. That is left over to the system. So as an example, screenshot here, you'll see a couple of proof test steps, and each of those steps have a pass-fail criteria type and the actual pass-fail criteria. So in this case, we're talking about a valve, and is it completely closed? And the answer is yes, no, and we want to see a yes. If during the test it's concluded a no, it's not completely closed, then obviously that will be a flag of, hey, the test has failed. But I may have another screenshot where we have transmitters where you're asked to, let's say, measure the 4 milliamp. So it's zero output, you expect 4 milliamps. You can actually put a tolerance on that value, and so let's say plus minus 0.05 milliamps. So if you record 3.99, you're still passing. If you record 4.07, you may not be passing anymore. But the user records the factual data, and then the tool will determine if you pass or fail. So that's the proof test generator. So you define a proof test for a specific piece of specific device, and you can assign those proof tests to the different addresses that these devices are used on. If you modify the proof test, you can apply that to all your devices. So there's a central library, basically, of these proof tests. The hazard scenarios, well, what they will allow you to do is they will allow you to document when there is a demand from the process. And when you set up a hazard scenarios, you indicate the sequence in which the different IPLs are expected to act when a certain hazard occurs. So, for example, a high pressure event, you expect the pressure relief valve to act after the safety instrument of function has failed. You expect the safety instrument of function to act after an operator would have failed, and you expect the operator action after a control function, for example. So if we know the order in which we expect the IPLs to work, we can simply record which one is successful and automatically know which one failed. And also know which one were not exercised. So let's say there's a high pressure event and the operator is successful. We know that the control function was not successful. We know that the safety instrument of function was never exercised. We know that the pressure relief valve was never exercised. Obviously, addresses are part of the IPL as well, so we can have clear location of each device in your plant. As an example, I have a high main fuel pressure scenario here for a burner, and we have some protection layers, the BPCS, a safety instrument of function, and a pressure relief valve, so we don't have the operator in this example. And I hope you can see this, but here on the left-hand side, the heater burner, we have the high main fuel pressure scenario with the different layers of protection that protect against that. Now, as I mentioned, you can configure SILStat from scratch. You can manually make your selections, specify your addresses, specify your devices, link them up. Or if you've used exSILentia, and I hope most of you do, but if you've used exSILentia, all this information is already recorded in the tool. So you can simply export out of exSILentia. Well, to be more precise, in SILStat you simply open up an exSILentia file, and it will automatically, configure your plant hierarchy, your devices, as well as proof tests. How does that look like? From an import function, you select the file. The tool is thinking a little bit. And then on the left-hand side here, you see a hierarchy that's created. You see the devices that have been specified, and you see hazard scenarios that have been specified. And that's a matter of a couple of clicks on a button. So that's your initial setup. And as I mentioned to you, well, if you've used exSILentia to do all your SIL verification, SIL selection work, the setup is probably done in 5 minutes. So it's very powerful. So when we get to the actual recording of events, this is where you want to be active. This is where this is the main live of the tool. This is where you're going to be using it. We can record proof tests, and we can simply identify an address and then follow the steps. And then, as I mentioned, SILStat would automatically determine if you pass or fail. So what we see here, we have the proof test recording. We've selected a specific test, and this is for a transmitter. So using a hard communicator, drive the output to 21.5 milliamps, drive the output to 3.75 milliamps, and you expect a certain value. You record that, and you can put any comments. You can also put images. So maybe not with the hard communicator, but maybe there are some questions that will ask, well, is there any corrosion buildup on the element? And you could say, well, you know what? I'll make a picture of that. So I have documented that right now there's no buildup, or there's a lot of buildup, and I want to document. So we can record those pictures as you go along with recording the proof test. So here we have an example. At the top, you'll see that for the 3.75 milliamps, we recorded a 3.89 milliamp value. Apparently, that's outside of the range. So it's immediately flagged as, hey, this proof test failed, this step failed, something is wrong here. You've lost some accuracy in your transmitter. In the example below, we've recorded 3.78, which is apparently within the range, the tolerance that we specified. So in that case, you see everything passed, everything is happy. You record your proof test events, and you have a record of the fact that you performed your proof test, and as you do your proof test, you have a record if that equipment worked as you expected, yes or no. I mentioned the maintenance activities, items like recalibration that may be required every so often, or the replacement of a pair, or preventive maintenance, maybe cleaning out of impulse points. All that can be scheduled, and you can keep track of the fact that you've done those maintenance activities. For example, a maintenance activity could also be a replacement of a device. The useful life of a particular equipment item may be 10 years. So you may schedule that every 10 years you need to replace that device. So you can record in the tool that, hey, yes, I've pulled this device out and I've put in a new one. And again, you keep track of where that unit is going. That may go to a discard pile, or it may go to stock room or whatever. A valve may be refurbished, or a workshop, and so on. But you can record the cause. You can record any comments as to why you performed a maintenance event if it's a non-scheduled maintenance event. And there's a list of maintenance tests that you can choose from, and these are eventually modifiable as well. But I think in this example we were doing a conditional maintenance that we recorded here. So then we get to the demand. So we've looked at the proof test that we need to do. We've looked at maintenance events. Also, if a unit just simply, or an equipment item fails during normal operation, that will lead to a maintenance event. So that's something you would record there. But the other aspect of things that we need to record as part of our functional safety are demands. And the standard focuses on safety instrument functions. It tends to not focus at all on any other protection layers, but reality says, hey, I may have a SIL1 safety function, but I took 2 orders of magnitude credit for my relief device. So you kind of want to keep track of this stuff. So we can use this information later to determine the actual frequency of the hazard scenario. I miss an O here apparently. And you can also use it to automatically determine which ones were exercised or not. So let me show you how that works. So we have a scenario here, a hazard scenario that occurred. So I picked a hazard scenario from my list of hazard scenarios, and I can simply say the low firebox pressure alarm, that one was successful. That automatically means that none of these others were exercised. The first layer of protection was successful. In the second example, I'm listing that the burner air fan monitoring motor running contact was successful, which means in this example that these 3 layers of protection failed. So I automatically record their failure. That leads to maintenance activity, and that I need to look into why these failed and so on. But in both cases, I may have had 2 hazard scenarios. So the overall demand of the process is at a certain rate, but in both cases I see that the safety instrument function was never exercised. So that's something that you can keep track of, and that the tool will automatically determine. So you can see demand rates of the process, or for a specific hazard scenario, you can see demand rates on the different IPLs. There's an event viewer where you can review all your events, and I got this out of a sample database. Doesn't show that many events. We have a couple of customer databases that I could have pulled things from, but obviously there's some proprietary information in it, so I kept it simple in this case. So that's the event viewer, and then there's a dashboard that is configurable. You can look at your scheduled proof tests. You can look at the proof tests that are overdue. You can look at your overall 61511 compliance status, so how many SIFs are out of compliance, which could mean that there's overdue proof test, overdue maintenance activities. Address-based statistics, so how often is there an issue on a specific address, how often is the issue with a specific device, a device-based statistic, and then finally, failure rate estimates. All that is configurable on the dashboard. And in this case, you may have multiple units, so you may want to order them or link them on certain units or specific areas. That's what we call, we have countries, facilities, sites in the examples here. That may actually be, those are all areas in the tool. We call them areas, and you can configure that. You can have up to, I think, 10 area hierarchy in your setup. So that's in a nutshell what the SILStat software does. It's very powerful. We have some customers that were initially interested in recording data, but realized that it's not just the recording of the data, it's also the ability to document and demonstrate that you're compliant, that you've done your proof test as that you've done your proof test for your requirement. Okay, I have a question here. If SILStat can be used for the proof test procedure and recording, then what is the requirement of other tool called the proof test generator? So that's a good question. In the original overview, I showed you we have a proof test generator, and then we have the more advanced proof test generator in SILStat. They're actually the same tools, or at least they will be the same tools. The objective is that when you do your SIL verification, when you're using the exSILentia software, you can specify what your proof tests are, and you can export those into the SILStat software. Now, the focus in exSILentia is on specifying what the different steps are. You can update that in SILStat, but the focus should really be in the conceptual design. You've assumed a certain proof test coverage. You may talk about a certain proof test coverage on a valve, and the higher the proof test coverage you claim, the more extensive your test needs to be. That's something that you want to document up front there during your conceptual design. That is exported to the SILStat software, and the SILStat software will then help you schedule those and help you record that you've done the proof test. So that's the two aspects. You have the configuration end of the proof test, which can be done in SILStat, but should really be done in the conceptual design in the exSILentia software. And then you have the recording of proof tests that you would do in the SILStat software. So it was a very good question there. So what does our offering look like? And I've kept it simple to a single slide. We offer two versions of SILStat. Actually, I think our brochure online only talks about one version, but we're in the process of updating that. We have a SILStat Lite version and a SILStat Site version. The Lite version is a single-user standalone application. So for those of you who have exSILentia standalone, it's exactly the same thing. You install it on your machine and you can use it. You can configure, you can record events. Obviously, you have a database on your local machine where you record all that information. The SILStat Site version is a multi-user environment with a central server-based repository. So how do you look at that? Well, there's a central server somewhere that records all your data, and that allows communication between a workstation that you can have to configure your site and devices and addresses, etc., as well as separate recorders. You could say that the SILStat Lite offering that is the same as just a workstation with an embedded database, whereas the Site version has all these different subtools. So you could have an administrator that is really making sure that everything is set up correctly, and then you have people that go out in the field with recorders that just simply record the proof test, that record the maintenance activities, and so on. The recorder is based on the initial release of the recorder is going to be a Windows operating system based recorder. We've had some concerns in the past with people taking out computer equipment out in the field. Obviously, there are ATEX approved devices available, computer devices available, so that's something that you can use to run this on. But one of my colleagues recently found a ATEX approved iPad case. One of the things that we will be updating, we had an original iPad recorder, and we basically halted the development of that because there was too much feedback from users that they couldn't take an iPad out into the field. But now that there are intrinsically safe ATEX approved iPad cases, now we can take those iPads out into the field and use them as a recording. And if you have a tablet, and I'm not promoting Apple, but if you have anything like an iPad, it's a whole lot easier to carry around than obviously a laptop computer. So anyway, that's the two offerings, a Lite and a Site version, easily upgradable from one to another, from Lite to Site, if you decide to extend your overall use of the tool. So what are the advantages and benefits? Why would you look at SILStat? Well, number one, you need to record proof test results. You need to record field failures. You need to record demands. It's mandatory for compliance with the standard. And this tool will allow you to do that. Now, you may have a system already in place, in which case you could say, well, I am recording the information. In that case, I just challenge you to look at how thorough and how complete your recording is. One of the things we've found is that people will tend to only record if they need to issue a work order or a purchase. You need to make sure it's used throughout the life. Now, in addition, the API recommended practice 754, process safety performance indicators for the refining and petrochemical industries, is mentioning or is addressing the recording of performance indicators that we need to do in order to be compliant with that particular recommended practice. And again, SILStat will help you in that. Why do you want to record data? Of course, you could say, well, I need to because I need to be compliant with the standard. Yes, but reality is we want to find issues. We want to find if we have problem areas. Maybe there's a specific address. Maybe there's a specific device that has issues. Maybe there's specific device types. Device types and all transmitters of a specific type. So you may have 100 particular transmitter in your site. You may find issues with a particular transmitter and decide, hey, from now on we should switch to a new technology or the different manufacturer and so on. So that's items that you can track while you are you can look for while you are recording data. That should help in reducing false trips. So in the end, your compliance attempts with standard leads to better data. Better data will lead to better design of your plant with reduction of false trips, better operational experience. So in the end, it makes your plant simply better. Data comparison. Compare your actual performance with your assumed performance. It's required. It's required that you do this, so you need the data. If your risk reduction is adequate, your performance is better than you assumed, then just keep collecting data. You don't necessarily have to change anything. If it's inadequate, then your risk apparently is much higher than you expected. You have to go back to the analysis phase in the life cycle and make sure that you've taken everything into consideration. Maybe you were a little bit optimistic. You assumed that the process upset would only happen once every, let's say once every 10 years, but in reality it's happening once every 2 years. That's a 5x. That could be a SIL level difference depending on your layer of protection analysis. If your risk reduction is more than adequate, then obviously your system is over-designed to prevent the hazard. Maybe you could redo your SIL verification and say, you know what, instead of testing once every year, we can actually test this once every 2 years or once every 3 years. Or you could choose, we're going to leave this system in place the way we designed it. We're going to keep collecting data. But in the future, when we have new projects, now we have plant-specific data that we can rely on. Plant-specific data that will allow us to justify, less redundancy, longer proof tests, and that's your basis for that justification. to have data for future lifecycle tasks, risk assessment, layer protection analysis, your SIL selection, as well as your SIL verification. That's what you get when you collect your data. You don't have to rely on your industry data books anymore, or you have verified that those industry data points that they actually apply to your particular plant. If you look at failure mode effect and diagnostic analysis data for specific equipment items, it's an average worst case environment, and it's expected that for a majority of all applications around the world, that data is applicable. Well, you may have a very benign process, and maybe you can justify an order of magnitude less, or you have a very harsh environment, and you're operating the equipment on the edge of its specifications, and maybe your failure rates are a bit higher. One of the things that we offer along with the SILStat program is that exida will review your data and provide detailed reports as part of your annual maintenance. And we will go through your data manually. Obviously, we have a couple of tools that help as well, but we will go through your data manually and see what's the quality of the data. Give you feedback on your overall collection process. How are you using the tool? What's the level of detail that you're recording for different issues? And we'll issue reports with your demand frequencies, with your failure frequencies as you have recorded them. Maybe weeding out some data that may not be applicable. Maybe you have systematic issues in there that shouldn't be accounted for in the random failure rate for a product. Maybe there's certain failures that are related to the product. Maybe certain failures are related to the maintenance process. We'll give you that feedback, and we'll benchmark that to others in the industry. So there's the data analysis and review, and that's part of your annual maintenance contract. So that's annual maintenance contract will give you free updates to the software. All future releases, you'll just simply get, but as well as the evaluation of the data is included. And of course, if you have multiple sites, then with the SILStat Site version, you can actually combine all that information. You could set up a central repository for all your different sites, and you can include the results in each and every one of the sites in your overall analysis. Of course, the more data points you have, the higher your estimate, or not the higher, the narrower your confidence limits are going to be on the estimates of failure rate and demand rate. So that's an advantage, of course, that you have when you have multiple sites, that you can combine it into one basically data repository. So with that, I've reached the end of this webinar. If there are any questions, feel free to ask through our Q&A at the top of your live meeting screen. Thank you for dialing in or logging on this morning, afternoon, evening, whatever it is for you. I appreciate that. I'd be happy to address any questions. Seems a question coming in without a question. All right, so very happy to do a presentation, Mohammed. If you have any questions, feel free to ask them now, or if they come up later, info@exida.com, info@exida.com. That's the area where you can send your questions to as well. A very good question here. Is there any kind of feature to integrate hard/common plant monitoring system diagnostic data into SILStat for instrumentation where it can be detected? The current answer is no, but we are working on that. I don't have a time schedule for it, but we are talking to some of the manufacturers to see if there's a way for us to integrate that information into the data that is being collected. out of SILStat, that is collected in SILStat. Right now, it's a standalone product that doesn't interact, but it is the intent for it to interact in the longer run. So one of the things that makes, there's a question here, what makes SILStat different if there are any other products? One of the things that I think speaks very well for the way that we've developed SILStat is, it's an out-of-the-box tool. You install it on your system, and assuming that you've used the exSILentia software to do your upfront safety lifecycle work, it's literally an import of that exSILentia project file. And you're ready to go. There's very little configuration needed. You can start recording your data immediately. I think that's one of the main things. I've heard of some similar products that are maybe focused a little bit broader than our initial focus, where consultants are on site for a year to help set everything up. That means you lose a year of data collecting. So we're really focused on getting you up and running as quick as possible, getting you in a position where you can start recording your tests, can demonstrate to your local authorities that you are compliant with the proof test schedules that you've assumed, that you are compliant with the extent of the proof test that you've assumed, the extent of the proof test coverage, and so on. So I think that's where our focus, our initial focus is on functional safety, and I think that's where we're very strong. But functional safety is just one item within the overall PSM, OSHA PSM, process safety management. It's easily expandable to let's say normal control equipment. Normal, your pumps, etc. But when it comes to demonstrating compliance, that's where the original focus was on, and I think that's what makes us, that's what makes the tool very different from anything else. All right, it looks like there are no other questions. I appreciate everybody signing on today. Again, if you have any further questions, feel free to send those at info@exida.com, and we'll address those. I'll ask that the recording is going to be completed at this point, and we will make that available later. One of my colleagues will also make the slides available, I think, later. So if you have any questions and want to review it later with one of your colleagues, you can always go back to that recording or look at the slides. So thank you for dialing in this morning, and stay safe today. Talk to you guys later. Bye-bye.